Okay, what I'm going to do is cover the comments that we had captured, either action items that need to be done, or thank you. That's fine. I deserve that, so I'll keep it myself close to the microphone. So anything that we thought was an action item that someone needed to do to check on data or revise any items, as well as limitations and general comments that we be sure we capture so that when we move forward in our evaluation, those are considered. So I'll just sort of step through these. The first day, a lot of that was review and summaries of some previous meetings. So we wanted to be sure we had a common basis for people to start with. So there was less sort of real recommendations and more introduction. We also had a long afternoon on the time in the afternoon going through the salmons maps and that basic approach. But let's start with some of the comments we had from our summary of the previous working meetings in January and other response from the developers to the questions that we had asked them from our last workshop in October. So we had higher sigma values for the ACAR model. It was controlled by fee, but not really constrained or explained simply by the number of recordings per earthquake. Could be related to quality of data or quality or uniform processing, or is it just more variable site conditions? It's not identified what's the cause, but the values are clearly much larger than what we've had in the other regions. The applicability of XM to near fault conditions. So we know that numerically it has issues at 0, but it does have this sharper distance slope in close. That's what we're talking about today. Remember, XM plotted outside of our range of models that we had generated just from the GMPEs. This is something that Gail has said is, again, behaving in the way that she intends, and she believes that this is a valid model for how scaling could extrapolate to short distances, but a minimum of not using our model at 0 distance where it, again, has numerical model or issues. And then, so make sure if I put something here or missed one of your comment that you made or misrepresented it, let me know. For splay faulting, for Kim, there was an issue of the 10 hertz large bump in the factor that needed to be understood what's happening if there's something numerical going on. Man. So one of the key issues we talked about using a common functional form. Remember the first day Nico showed using our rupture distance-based common form and applying it even to the RJB metrics. And the recommendation that we actually do 2 separate forms. Once the common form is RJB based, the others are rupture based, so that we can maintain some of the key features of the model and not lose them through the common form. The standard deviation to the fit, that's a measure of how well this common form is parameterizing the model. They're getting their revenge here, so that's okay. So we measure the fit of how well we can parameterize that with a common form, and there's simply a standard deviation of the fit. If that number is less than or greater than 0.2, then we worry about it. Otherwise, it'll have too small of effect on the standard deviation and we can ignore it. Otherwise, we can bring it into the aleatory term. The other, on the 1,000 models, Brian had commented about this before, that you could find a different or improved common functional form which wouldn't have as many non-physical or behaviors in their extrapolation. Right now we've been using a very simple model that when you push it too far, it will not extrapolate in as consistent way. And suggesting to see if we can choose a better form for that. Am I doing this right? I'm just trying to scroll. So I keep using my two fingers as on my Mac, and it doesn't do anything. So, okay, next one down. Okay, thank you. All right. I want up because we can't quite see the whole. Yeah. See, she's having trouble too. I'm feeling a little better. Okay. The covariance matrix. This is the matrix of coefficients and how they are correlated, right? So that we can create our 1,000 models. You could do this using a mixed effects model with individual GMPs as the group factors. So this is a superior statistical approach to the problem. For our schedule, we'll be using likely this approach because it runs faster for deriving the models. But we're going to look at trying to use this random effects approach. The other issue we face is how do we remove our non-physical models if we have a functional form that generates some of those. So some parameterizations may exceed, a parameter might has a physical limit that if it changes sign, it means something different, and we don't want to create those. So we can add constraints to the sampling or constraints to the covariance structure or find a better functional form that leads to more stable models. Okay. Now you're going to leave me to do this myself, right? I push on it and nothing happens. Oh, the bottom is the clicker. Ah, okay. Okay. Thank you. All right. The other way is to transform the variable that maintains it. So what Nico said, okay, if you don't want a variable to go negative, a coefficient, you square it in setting up your distribution. You can do that, but then it gets a little messy in that it may not be a good approximation of a normal distribution for that coefficient. Okay. Success. Okay. The other part is when we're comparing the Salmon's map to underlying data, we can't just use one subset of the data. We need to use many. We talked about that again today. The best is to take a data set from a given GMPE, apply VS30 corrections consistent with the model that was used, which selected that data, and then we can use that to evaluate all of the models and then try a different set. We want to see how stable that structure is below these models and how much it would really change based on whose data set we're using to compare the data. Okay, so this is going to let us again define limits of what data will allow, different terms in the GMPEs, so that we're here, do not weight expert judgment by considering only data. That is, we're not trying to find a model that best fits the observations only. That sounds a little counterintuitive, but we're not looking for a non-parametric model that best fits a short range of data. We want a model which scales properly, following some basic seismological theory and behavior on how magnitude scaling should occur, how distance scaling should occur, and so forth. Okay. The other part is we had epistemic uncertainty in the each individual models that was characterized by what we call our Bob and Linda models. But that's, we need to show that that uncertainty is at least as large as what we've got, or that we bound this uncertainty, and we could bring this along and add a range to our current models by creating a new model, take one model and make several versions of it, sampling that uncertainty space, or just show that this is small compared to the range that we're already generating from our 1,000 models. And Nico showed that even when he put this range on the highest and the lowest GMPE, he got a bigger range out of his 1,000 models. Okay, day 2. So we now are through day 1, through your review. So hazard sensitivity for Palo Verde, we need to go and show those in a way that we can isolate one branch of the logic tree at a time. So right now we are seeing combinations of effects, and we want to do those one at a time. We want to change the base model, which had been the old NGA West 1 models, as just using those. We're going to instead change to our average or weighted, equally weighted models from our candidate models. We had a couple outliers. Remember, there was a big outlier in the 10 to the minus 6 calculation that we need to check. And then the phi-SS sensitivity looked to be going the wrong direction, so we need to check that one. Did I go too far? Logic term tree, so Tom, he noted that logic tree term can be confusing. That if you're not used to calling it that as we do in this business, we will, at least in our document, say exactly what we mean by logic tree, which is a set of alternative with weights which sum to 1 on each of the branches. And adding the branch for a fat tail or a log normal. Right now we had only really treating this as always fat tail. We can bring along an alternative. It may end up with 0 weight on that, as that is appearing to be a much better model for the data. Okay. These should be all things you saw the other day. So on the Arizona host zone, we needed to demonstrate that using an RJB distance metric common model adequately captures hanging wall effects. Okay, so we think it will for the limited range of dips and magnitudes that are controlling it, but we need to demonstrate that. We wanted to show the confidence intervals and the normal style of faulting factors. Those are pretty broad confidence intervals compared to the factors themselves if we're just using subsets of the NGA West 2 data due to our small number of normal faulting events. The other part is we had mentioned some of the GMPE developers put constraints or biases into the normal faulting factor, bias towards 0, if that factor seemed to be going very large with not a good constraint or not smoothed over period. And so we can document what cases and what the justification was for that, so we can help understand the interpretations when we're comparing these generated models as well to the data. Adding the models that weren't used to the covariance in the covariance matrix onto the Salmon's plot so we can see where they fall. That may help us as well identify regions that have a limitation to them. We need to address strike slip sources in the host zone, okay, not just the normal faulting events. Something is beeping. Is that, okay, it stopped. We have to deal with strike slip sources, but we'll likely, since these are likely to still be the dominant normal fault, I think we'll focus on the normal faulting model and make a style of faulting correction to bring it to strike slip as a way of applying that. And the other part was adding the road signs onto our
mouse in the middle.
mouse. Thank you. Adding, we'll call it this road signs to the salmon maps, giving you the direction of magnitude scaling or distance scaling, depth scaling, and so forth, so that you can get an idea what it means to be moving one direction or another. Later we talked today about rotating them all to a common x-axis, always being let's say orthogonal to the contour plots for the median scale factor as a way to keep the models, get a sort of standard direction when we want to look at these things to help us. Okay. I think I figured this out. Your whole mouse pad isn't a clicker, right? And I have to find the right spot. Okay. Comparisons to data. Did we already? That was still in day 2. Comparisons of the Arizona data for the distance stations. So there's some outliers. So for Campbell and Buxorgnia event 280, El Mayor Kukapa event at 1 hertz, we had a jump. We want to make sure we have your right event term for that. And then event 1017 for Cho and Young's at 5 hertz was sticking out. We want to double check that one. And then we had a comment, we need to provide a clear scientific basis for no change in the distance scaling from California to Arizona if there is a change in Q. Okay, and that's got to be an explanation how that all works. For the average source term, or for distant sources, we can add event terms from NGA West to events that were not recorded at the TA data, which had been our current subset. When we're just looking at how do event terms in that part of California compare to average event terms. Are they on average 0, or are they on average higher or lower? Okay, so because we're getting a big enough data set there that we can now tell, all right, my event terms, let's say we're average 20% higher or 20.2 or minus 0.2, then I can build that into the centering of my model. The other part on the logic tree, we built a logic tree for the path effects from the northern and southern zones, source zones to Arizona, but we should have a 0 path effect where it's behaving the same as California. Okay. So we spent a lot of time yesterday on sigma models, phi and tau, and what that's all about. So that's all trying to capture statistical estimates of what the ground motion variability is and figuring out how that is applicable to our particular condition. And so how much of the worldwide data can we use for that, and how can we isolate what are the different contributors to those parts. So one issue that came up was apparent correlation of VSS with VS30, and we saw a fairly strong correlation, and what is causing that? I think the most likely explanation that came out of the discussion was that it's due to, maybe explained by spectral state variability for rock sites, and so we can easily numerically simulate that and see if that creates the kind of trend that we were observing. For the southern zone, the phi SP-R, so single source to similar path to region is what we call that for the within event variability, was going up for the southern sources as opposed to going down. And our framework of our model is we get reduced aleatory but larger epistemic uncertainties as we start to add these in. And so we want to check this for a narrower range of sources to see if we just use the sources in the south or just in that central region, would one of those or either of those working by themselves produce the shift in the expected direction, or are these just simply more variable? And that's possible as well. That would be an area that has higher variability in the path terms. Another key issue here was the uncertainty in the VSS term. So we can go around the world and calculate at each site that has 5 or 10 records, what is the standard deviation at that site? And we do it at another site, and so from that we can see how stable is our estimate of the standard deviation. But there's a strong bias due to small sample sizes. So when I only have 10 or even 20 recordings, I'm going to get a systematically larger uncertainty in what that, or a large uncertainty in that's simply driven by the uncertainty or by the statistics of the small numbers, and isn't really saying if I had a large number of samples at each site, I would have this range of what the value is. So Adrian had showed a way that he was doing simulations in a forward way to show what is the potential effect, and that we need to correct for that, and this is about half of the size of the variability that we're observing. So that's an important feature to take out so that we get an appropriate range in our epistemic uncertainties. Okay, then I think we're, so upper tail of phi, so we're, extreme events are driven by the distribution of the ground motions and the behavior of the upper tail. What Bob showed was the mixture model of putting two normals together can capture the shape of the broader tails that we're seeing right now, and it also can represent a power law distribution. So he showed both of those and that they're very similar up to at least 4 standard deviations. So this one shape of the model works pretty well for capturing that behavior, whether it's power normal or modeled as a sum of 2 normals. And sigma models for tau. So we talked about the putting breakpoints in the magnitude scaling for tau to simplify and smooth through the breakpoints considered in each of the GMPs. So we didn't want to have as much jaggedness in there. The issue of tau really being period dependent or constant was discussed, Some models are period dependent, but the average model, which was period independent that Linda showed, may be driven by the exclusion of the Zhao tau, and so we want to check that. And as along that way, evaluate applicabilities of that Zhao's tau model at the large magnitudes and long periods where it's changing. And that's, we can make sure that it is applicable, but we may need to treat it separately.
And it's not applicable to a small magnitude.
That's due to his data set that he used, right? He just only has a big magnitude tau. Okay. All right, thank you for that. So, day 1 and 2, if you can remember back to those days, were there any main things that any of you mentioned that we think we haven't captured here? Yesterday we were a little rushed trying to get this together, so if you can think back to yesterday and something, your brainstorm that you had and you said it, and now let's try to find that again. Gabe.
No, on the issue of the reconciling the Q values in Arizona with the observation of the ground motions, the one piece that it may well be that the longer Q is also accompanied by a long duration. So even though the Fourier amplitudes show a slower decay, the longer duration cancels that out and compensates for that.
So something like that. Okay. Any other comments from yesterday in particular? Ken.
I have a note here about needing additional data to get the source term for the from the long distance data to Arizona, right? Did you cover that?
Yes.
Oh, sorry.
I'm trying to see where we had that. But yes, right here. Average source terms add the events from the NGA not recorded in Arizona, so one's not in the TA. So we've got that. Anything else? Okay, today, so tornadoes plots that were shown today, we want to change base case to be the average again of all candidate models with equal weights. Again, isolate a single parameter in each of the branches in the logic tree one at a time, so that we're averaging for a, let's say, a given phi model averaged over all of the GMPEs, and then the next phi model averaged all the GMPEs, so that we're just pulling those numbers out, right? Add the effect of the combined phi and tau in there as a one of your rows in your tornado plot, so that we're basically lumping two branches of the logic tree together and seeing what those branches are. Okay, Nick, is that making sense? All right. Okay. Salmon's maps. So, how to make them easier to understand. John has already left us, but I think we got what he'd asked for captured here. Show that the common form gives an adequate fit to the published model. So that's just in magnitude and distance sort of scaling that we're normally used to looking at. how to exclude non-physical models from the set of simulated values, rules and how that is done, how to interpret the salmon's plots. Okay, that was John's 3 things that he says need to get fixed before he knows or is confident in using them. And we talked about rotating them to have a similar meaning in a given direction. So we just talked about that earlier, such as making the x-axis the direction for changes in the median. Okay. Then adding a metric as well, sort of a number on there to measure the ability of the 2D projection and distance space to capture what's happening in the higher dimensions. So we could have how much of that, how well is the correlation of the distances in the 2D space versus the higher order space? I think that's what you're asking for, Jack. Is that right? Yeah. Okay. So that gives you a way to judge these things that you have an adequate parameterization. Okay, so I had to put my, what I think I'm summarizing Kim here. So now that we all understand these maps and how to use them, that we should incorporate this method onto the broadband platform to help modelers of those developing the simulations evaluate and compare their results. So this is our flagship slide from the last 3 days. That was the most rewarding comment I think we could have gotten through the whole thing. So, okay. The models. So the 1,000 median models issue correlation between the strike, slip, and reverse models. So we want to try to keep those things together if they can fit, such that when we run the hazard, we're running them for a consistent set of models for both strike, slip, and reverse. So we're going to find a method to capture this correlation of the ground motion models for the strike, slip, and reverse parts for the way we make the models used for the hazard calculation. So I'm not going to tell you how we're going to do it, but Bob and Nico will solve that for us. So, tonight, he said, so great. You can see I am not a PC person, so this is a nightmare. Just, yeah, thanks. Okay, so we saw that when we tried to do sampling in the salmon space, looking at all periods at once and picking models that would sample that distribution, that would work for the distance metric measured over all periods at the same time. But when those models were then individually plotted on a salmon's map for a single frequency, they don't fully sample the space. So we're going to have to do something different. So we need to consider period-dependent weights or multiple period-dependent models, so the models wouldn't change. Or we'd have different models with weights or a set of models where we're changing the weights. But we're going to have to do something different than the simple approach we thought of just using one set of selection in the space of all models. And really that's back to models that may be very similar at one period, could be very different at another. And if we put them all together, it just says over all that range how similar they are, not over each of the periods one at a time. Okay. Directivity, so we need, yes.
Something that we didn't talk about. I really think it's a good idea to have a report, a peer report type about the methodology, details, and so on, examples, and so on, besides just journal publication.
So, I'm just going to put it in here separately. So Doc, just give me any blank one, yeah.
Norm, you can only be chief, not master.
Okay, documentation, right? So, so we're going to be saying the use of a peer report documenting the methodology. We're also going to have a tool that implements it, right? Yusef, is that more, so you want, I mean, I'll just say, okay?
Okay, if we can go back to where you had the tasks on the salmons maps, just before we went into this. So we talked about adding models so that we sample the data space for the likelihood function. For once, when it looked like we might have had more data than models to capture. You follow me?
Add models to capture the full,
To go wider in the range, you remember the likelihood looked like it wanted to continue?
Yeah,
It was, we
yeah.
didn't have the moat
yeah.
around it,
So it's really, if the likelihood function is not,
captured completely.
isn't bounded, so to
Yeah.
speak, then broaden the range of models.
Yes.
Right. Is that it, Christine? Okay, thank you. Others? So that we want to try to go out and push or establish what are the bounds. And if we haven't gone out far enough, then that needs to be broadened, okay? All right. Okay, can we go to directivity or more Salmon's Maps questions? Does anyone dare? No. Hey, Bob is asking for a different color scale on the background. All right, directivity. So we showed the sensitivity of the analysis shows that this has been a significant effect. And if it's that size, as we look at the other periods, then it's going to be big enough that we need to capture this into the logic tree. All right, so we could have uncertainty in our directivity model due to the limited data that was used to derive it, so we can do that part. Or we could be also capturing the range from what other models might do. That is broadening out this narrowband model to capture parts of a broadband model. That's an issue as to how much we can capture with this form versus how much we need to bring in a different sort of scaling of the form of the directivity. Our difficulty with any other functional form is it's not centered in the GMPE space. So that's really something we need to be careful about. Brian, did you have any suggestions or comments?
Regarding the other directivity models not centering in the equation, but I think you can center their prediction after you calculate the directivity over a large footprint of sites, then you can just center them instead of, yeah.
So,
It's not in the model, but you can do the centering
right.
in your application.
So centering can be done, right? There's nothing stopping us, but then right now they haven't been, or that information wasn't provided, but we have to work through the centering of each of the parameters. Okay. Is that capturing that, Brian?
And I have a question. You have done strike slip and reverse earthquake for directivity. Do you have a reverse oblique earthquake in your source model?
Yes.
Okay. So
I would say, Hans is here. Hans, do we have a reverse oblique? Or are you making just reverse and strike slip? We have reverse oblique. Okay, so they have reverse oblique.
Okay. So reverse oblique, I think we have a different pattern than what you get from the reverse.
A different what? Pattern? Okay, but a different adjustment, right? Okay. Different than reverse, right? Okay. Yeah. Anything else from today? Okay. Hanging wall effects, I think we could say the hanging wall effects are still not constrained well constrained empirically from the empirical data. And from Ed, he's saying we should be considering the limitations of the simulations in developing the models because the empirical data don't have enough to get you there. We are right now relying on the simulations, but I think that's his warning to us to be careful of that part. Is that a fair summary of that, Ed? Thank you. All right. Path effects, so if we include a path term, then we need to develop a consistent fee model, so we need to have the pieces going together. As Adrian noted, the FESS has the path term variability folded into it as in the worldwide average term there. Before we can charge forward with this, we're going to have small data, but we also want to check that the response spectra factors that we get for these small magnitude events are applicable to response spectra factors for large magnitude events, that is in terms of the effect of the spectral shape. And this is really back to Fourier spectra scaling versus response spectra scaling to make sure those numbers can move around. So this is back to a response spectrum. Its peak value is not a linear operator, and so we need to be sure it's working properly. That's the last one I had. Anything else that any of you wanted to be sure we capture in the notes of the discussions? No, okay, I think people are tired after 3 days. So, save that, okay? I'm gonna leave this to, Corolla because this is, yes. Can you just come save this one?
Now I got it. It's green now. If I remember correctly, this is stated that this is the third of a 3-workshop process to get this job done. What is the path forward beyond this point then?
So what we have done is gone through our framework on how we are planning to do the evaluations, and we're going to take back the feedback and recommendations on changes to those approaches. So we'll be then building those models. We'll create a draft report, and then the PPRP will review that. We'll meet with them to go through the details of what each branch was done and how the model was structured and why did we have a 0.3 weight on this branch and a 0.6 on that one and a 0.1 to have adequate technical justification. That work will all get done through the summer, so the models will be complete in July. Hazard calculations will then start to be run. The reports of all of this won't be issued until the beginning of next year, but they'll be essentially the technical work will be finalized by early August, because that's what we need that done for the hazard calculations to run, and then site response to be done following that. So these are due into the NRC in March of 2015, but including the hazard calculations and the site response and the full set of analyses.
Now, you mentioned somewhere in there that these SOMANs, is that plots are going to be, turn out to be actually very illuminating. They're very, actually they capture the essence. And I did download the paper that was written.
Can you hold the microphone closer to
by
your
the
mouth?
professor that you worked with. And you're a co-author of that paper. And it's actually very interesting to see that. And now, how are you going to, you said, you promised that you will expound upon that and have a tool that all of us can use. How and when and
so that part
and
is,
which
so we do work with the universities and we do work for these Swiss projects. So we'll be documenting what we're doing in our evaluation, but we'll work with USEF. I mean, Nico is a postdoc at Pierre, and he's here for a year to write this up and explain us how to do it. So this is really his next focus is the documentation of that and passing on this tool so that other people can run it. Exactly. And then making a peer report on that part of it.
Norm, I forgot that you had it or not. First day, I believe, I mentioned that I think it's a nice idea to have a strong interaction between this group and the site group. Because there are, you're passing a smoothing of tau to the other, lots of interactions going on.
Okay, I'm just going to stick it here so we remember where it is. Okay, thanks, Yusuf. Ken.
So another interface issue that you didn't sort of capture here, but you had mentioned was to make sure that you go back to the source characterization teams and make sure that you are in fact addressing all of the source characteristics that you may need to vis-a-vis the surprise that they were looking at strike slip events in Arizona.
Okay, does that work for you, Ken? Okay, thanks. Chris?
Yeah, back to the interface with the site group. Carola and I sat in on the shack for the Hanford project. And their site group was tasked with developing a specification to ensure that the information that was turned over to them would work for them. And I believe, do we have that? Did we asked for it. We have a draft of it, so you don't have to start from scratch with figuring out how to interface with them, the site group.
Yeah, but he's saying it's coming from the site response people, not from the ground motion. It's not ground motion to site response, but the site response back to the ground motion group?
No, it was a site group's writing a spec for what they wanted to see to be able to achieve.
Right.
Yeah.
So the site group wrote this and gave
Yeah.
it to the ground motion group.
Right, right.
Okay.
That's how I understand it.
Since I have some interaction with that project. Yes, so basically what we did was we had an interaction with downstream users about what they would need to do the site response analysis and making sure that we were giving it to them. So they wrote a specification, they sent it to us, and we rewrote it so that it was more appropriate. And went back to them, and they agreed with it. So basically, a document that clarified what the ground motion characterization, what the hazard was going to produce for them in terms of the rock hazard. It's a little different here in that the Hanford is doing the rock hazard as a part of one group, and the site response people are separate.
Right.
Whereas on these
What-
projects, the hazard and the site response is more in the same group.
Yeah, we're sort
But
of.
at least it was clear that everything that was going to pass down from ground motion characterization was going to meet the needs of the site group.
Yeah, I agree with everything that Bob said, but I think one important difference is that in the Hanford project, the site response and the hazard are separated in time. Here, as Bob said again, they are almost simultaneous, or at least with significant overlap, and they are talking to each other as both projects go along. In Hanford, does not happen. The site response may be done later, may be done differently for different sites within Hanford and so on. So I
So-
think those
So it's
things make a
important for that, in that case, to have
Exactly.
it clearly written down. But we
Exactly.
should still have it, I mean, just to make sure we've thought it through
Yeah.
and write
Yeah,
it down here
and
as
we-
well for both
Yeah, and we
sides.
talk about interface issues all the time.
Right.
So that's being sorted out as we speak, and I'm sure once this project says things to the two projects, to Diablo and Palo Verde, there might be some give and take.
Okay? Anything else?